We're still continuing the conversation on tree diagrams or an ordered list to help us visualize and predict all of the possible outcomes given certain sort of scenarios, like what is the expectation of an outcome for a certain event, and what if there are multiple events that we're layering together, like in the scenario of choosing our class officers, voting for president and vice presidents, really voting for president, and then the second level is whoever got the second number of votes. We're going to continue on. This is 3C. It's a continuation from the previous page, previous question. How many outcomes result in Jordan or Kelly? So that word or is super, super critical and necessary to help us explain. We're going to be allowing two different things to possibly happen, and that's an add scenario. Or means add in probability. And is a multiplication problem. It's a combination of the two together. So we want a scenario of Jordan or Kelly as presidents, and, which means combined with, Taylor or Gray. So the word or comes into play. Or is an add sort of mathematical principle. How many outcomes result in Jordan or Kelly as presidents and Taylor or Gray as vice presidents? Well, let's go back to the tree diagram. Let's just outline. Jordan is this path. I'm kind of running out of color here. Maybe let's go with yellow again. So Jordan is this path, and Kelly is this path. Oh, good choice for yellow. Now, Jordan or Kelly are those two choices. Then as we go down those branches, we also want to consider back here Taylor or Gray as vice president, because that's what question 3C asks about. So Taylor would be this path. Jordan president, Taylor vice president. Or Jordan president, Gray vice president. So there's actually two outcomes. Kelly with Taylor vice president or Gray as vice president. It looks like a total of Jordan president, Gray vice, Jordan president, oh my gosh, J, Taylor vice, Kelly president, Gray vice, or Kelly president, Taylor vice. There's a total of 4 outcomes. Here they are. Write it in again. Jordan Gray, Jordan Taylor, Kelly Gray, or Kelly Taylor. There are 4 outcomes for president, vice president with this scenario happening. Now, if Bentley used the first initial of each student's name as an abbreviation in his sample space, so he included JM and MJ, which we've done, JM and MJ as different outcomes. Caleb is saying that those 2 outcomes mean the same thing, and you should only include 1 in the sample space. Notice, we did discuss this in the previous video, page 778, so go back and watch it, but think about that right here. Maybe go back, click that video, rewatch it again, or think back to when you saw it. How would you answer question 4? Is it necessary to include JM and MJ? Do those mean the same thing, or do they mean separate things? And how would you justify who is correct? Is Bentley correct, or is Caleb correct? I'm going to leave this one blank because you need to answer it. You need to explain your reasoning. I believe in your capabilities. I'm going to say pause the video here and write. Then as you unpause the video and move forward, we're going to answer question 5 together. Maybe you pause and you're back. Let's answer question 5. Can you rearrange the tree diagram to produce a different number of total possible outcomes for the election? No. Every scenario is there. The only rearrangement of the tree diagram would be to shift the letters around, but you still have to have 5 letters representing the 5 people who are running for election. Shifting the letters doesn't remove, what is the word? It's outcomes, possible outcomes. This is actually like the previous activity with the pizzeria. You can change the order that you request toppings and pizza size and shape and thickness of the crust, but you're still requesting the same number of things and you're still making the same number of decisions. As long as you can make the tree diagram look different, but there's still the same number of choices or outcomes, then they're going to produce the same number of possible total outcomes for the election. Consider the sample space from Pizza Special and Student Council. Does choosing a topping for a pizza at Mario's Pizzeria affect any of the other choices you have? No. You can pick pepperoni pizza independent of picking large pizza. So the pizza topping decision is not influenced by other choices like size or thickness or like shape of the crust. Because of that, that's called something called independent. Our outcomes are independent. The same scenario is not true for number 2, for the sample space for student elections. In that one, if you pick Jordan as your president, or if these group of students do, Jordan cannot be chosen as vice president, so Jordan is out. And so your decision for president does influence your choice for vice president. Does electing a student council president affect the choices for vice presidents? Yes, wholeheartedly. This is dependent as an outcome. Dependent outcomes. So if you pick your president, that person is no longer eligible for your choice for vice president. You have removed their, event for vice president from the sample space. The president choice or option, the president outcome, that's a better word, is removed from your choice for the vice president outcomes. That concludes our activity 2 scenario. What I want you to acknowledge here is that we've talked about all possible outcomes, and we've used the visual structure of a tree diagram to do that. In a tree diagram, you list all possible answer choices. It's really helpful to have color to make it be, I'd say prettied up, but at least it makes it have a better, deeper connection for us on what path are we following through the diagram. Thank you for watching this video. Thank you for clicking forward. The next one up is 780, a new activity by continuing to talk about probability and sample spaces. See you then. See you in the next episode. Thank you and have a good one.